In this section we are looking at parametric equations of curves. First, a few examples of what we refer to as Cartesian equations of curves. First example, x squared plus y squared equals to 4. Second example, y equals to 4x squared. And third example, y equals x times the square root of 1 minus x squared. What do you notice here? You only see x and y. Okay? Now when you only see x and y, when you are given an equation of a curve, that equation is called a Cartesian equation. Again, if you are given the equation of a curve and you only see x and y, then that equation is called a Cartesian equation. The reason for this is because x and y are referred to as the Cartesian axis. Okay, again, an equation of a curve in which you only see x and y, we refer to it as the Cartesian equation of the curve. Now we are going into parametric equations of a curve. So here let's look at x equals to 2 sine theta and y equals to 2 cos theta. Now what do you notice? Here x and y are expressed in terms of a third variable, and that third variable is theta. So we are given the equation of a curve, but x and y are expressed in terms of a third variable, theta, and that third variable is called the parameter. Okay, so x equals to 2 sine theta and y equals to 2 cos theta are parametric equations of a curve. So let's do a little bit of cleaning up. Yeah, if x equals to 2 sine theta, then you know that sine theta equals to x over 2. Just bring the 2 to the left. And if y equals to 2 cos theta, bring the 2 to the left, you will get y over 2 equals to cos theta. Now we know from our identities in trigonometry, sine squared theta plus cos squared theta equals to 1. So I have written x over 2 squared plus y over 2 squared equals to 1. Okay, now if you clean this up, you will get x squared over 4 plus y squared over 4 equals to 1, and multiplying throughout by 4, you will get x squared plus y squared equals to 4. So we started with the parametric equations of a curve, and we ended up with the Cartesian equation of the curve. So that's what I have written, a very important line here. We have gone from a set of parametric equations to the Cartesian equation of the curve. Again, we started with a set of parametric equations for a particular curve, and by getting rid of theta, okay, or rather by eliminating theta, we are able to arrive at the Cartesian equation of the curve x squared plus y squared equals to 4, where we don't see any theta here, only x and y. Okay, so frequently we are going to be given parametric equations, and from there we will have to write the Cartesian equivalent. So generally we either use trigonometric identities to do that. Again, many times we are given parametric equations and we will be asked to write the Cartesian equation of the curve. So to do that, usually we use either trigonometric identities or some basic algebra. Okay, now usually in our questions the parameter is either theta or t. So let's look at an example. Yeah, let's read the example carefully, see what is required out of us. We are given a curve defined by the parametric equations x equals to 2t minus 1 and y equals to 4 minus t squared. In part A, you are asked to find the coordinates of the point where t is 7, B, find the value of t where x equals to 15, and finally find the possible values of x at the point where y equals to negative 5. Good. Let's write the parametric equations again. X equals 2t minus 1 and y equals to 4 minus t squared. A, they ask us to find the coordinates of the point where t equals to 7. So basically what you need to do is find the value of x and y when t equals to 7. So now we can look at the solution. T equals to 7, plug into 2t minus 1, you will get the value of x. So 2 times 7 is 14 minus 1, you get the x value as 13. And when t is 7, you plug into y equals to 4 minus t squared. So I have 4 minus 7 squared, 4 minus 49, I'll get negative 45. So to answer the question, the coordinates of the point where t equals to 7 will be 13, negative 45. Not difficult, yeah? Just find the value of x when t is 7 and find the value of y when t is 7, and we're done. Part B, find the value of t where x equals to 15. So same idea as A, but this time we are given the value of x, which is 15. So plug in 2t minus 1 equals to 15. This is an equation we can solve. 15 plus 1 divided by 2, t equals to 8. In part C, they ask you to find the possible values of x where y is negative 5. So when y equals to negative 5, we have to go ahead and find the values of t first using the parametric equations given to us. In this case, y equals to 4 minus t squared. So you can go ahead and write 4 minus t squared equals to negative 5. So if you clean this up, you will get t squared equals to 9, and therefore t equals to plus or minus 3. So you know x equals to 2t minus 1. So all you have to do is take positive 3 first, plug into 2t minus 1, you will get 5. And when you take t equals to minus 3 and you plug it into 2t minus 1, minus 6 minus 1, minus 7. So you get two values of x when how do we do that? We get two values of x because we have two values of t. One value of t is plus 3 and one value of t is minus 3. Okay, that's why the question says find the possible values of x. Okay, let's look at the note that I have written. Okay, let's look at the note. To determine the Cartesian coordinates, this is important, yeah? To determine the Cartesian coordinates, that is x and y coordinates, plug in the value of t or theta given. Again, frequently we have to determine the Cartesian coordinates, okay, that is the values of x and y, and what we have to do is to plug in the t values, yeah, or if they're given as theta, we have to plug in the theta values. So I've given you a quick example here. If x equals to t cubed minus 1 and let's say y equals to t plus 1, these are parametric equations of a curve. So let's say t equals to negative 2, you can find the value of x, yeah? Plug in negative 2 here, negative 2 cubed is negative 8, minus 1 is negative 9. Okay, and to find the y value, just plug in negative 2 here, negative 2 plus 1 is negative 1, and you have your Cartesian coordinates minus 9, minus 1. A similar example, taking the value of t equals to 1, all you have to do is just plug in the 1 here. 1 cubed minus 1 is 0, and when t equals to 1, y equals to 2, so you have a set of coordinates 0, 2. Okay, so what's the point in this? All you have to do to determine the Cartesian coordinates will be just to plug in the value of the parameter, whether it is a t or a theta. Good. Now let's look at an example. Given a curve with parametric equations x equals to 1 plus sine theta and y equals to 1 minus cos 2 theta, find the Cartesian equation of the curve. The idea behind questions like this, you will be given parametric equations and you'll be asked to find the Cartesian equations. Remember the idea that I mentioned earlier, we have to eliminate theta. Usually we will use trigonometric identities. So good, let's start slowly. X equals to 1 plus sine theta, therefore sine theta equals to x minus 1, that's easy. Y equals to 1 minus cos 2 theta, so you know that cos cos 2 theta equals to 1 minus 2 sine squared theta. We know this from trigonometry. So cos 2 theta, I've replaced it with 1 minus 2 sine squared theta. So if you open this up, 1 minus 1 is gone. I'm left with y equals to 2 sine squared theta. What is sine theta? X minus 1. Plug that in. Okay, and if you expand this, you will get your final answer, y equals 2x squared minus 4x plus 2, and we are done. Okay, remember the idea, we need to eliminate the parameter. Our next example, we are given the parametric equations of a curve x equals to 1 minus t over t and y equals to 1 plus t over t. Again, x equals to 1 minus t over t and y equals to 1 plus t over t. We are asked to find the Cartesian equation. Now, when we are given parametric equations, to find the Cartesian equation, like I've said before, we need to eliminate the parameter. Yeah? In this case, we need to eliminate t. So we can use some algebra and do that. So let's just go ahead. Now, from x equals to 1 minus t over t, okay, take one of the equations. I've started with x equals to 1 minus t over t. If I bring the t up, cross multiplication, I'll get tx equals to 1 minus t, and then I'll bring the t to the left hand side, so I can write tx plus t equals to 1, and then take out the t, you'll get this. Okay, tx plus 1 equals to 1, and therefore t equals to 1 over x plus 1. So what have I done? I've taken one of the equations and written t as the subject. So t equals to 1 over x plus 1. All I have to do is plug into the second equation. The second equation is y equals to 1 plus t over t. So where you see t on the right hand side, plug in 1 over x plus 1, and that's what I've done here for you. Okay, now you have to be careful. Do the algebra slowly. Don't make any mistakes. Now, when you clean the algebra up, okay, we have an LCM of x plus 1 at the bottom. Okay, so you get x plus 1 over x plus 1, the numerator. The denominator is 1 over x plus 1, so this x plus 1 and this x plus 1 will go. So you're left with x plus 1 over 1. So, okay, so this x plus 1 will go. So we are left with x plus 2 over 1, so you will get your final answer, y equals to x plus 2. So, to summarize, we have eliminated, let me say that again. When we want to find the Cartesian equation, we eliminate the parameter. So I've taken one of the equations. In this case, I took x equals to 1 minus t over t and wrote t as a subject. Then I've used that and plugged into the second equation, cleaned up the algebra, and I've got my Cartesian equation, y equals to x plus 2. Now, as a check, the right hand side here is x plus 2, so we can write 1 minus t over t plus 2. If you clean this up, okay, you will get 1 plus t over t, which is y. So you know you have got it right. Good. Now let's look at the next example. Let's read the question. Given parametric equations, x equals to 2 cotangent theta and y equals to 3 cosecant theta, we are asked to find the Cartesian equation of the curve. So x equals to 2 cotangent theta, so cotangent theta, it will be equals to x over 2, and if y is 3 cosecant theta will be y over 3. Now we know this identity from basic trigonometry. We know that 1 plus cotangent squared theta equals to cosecant squared theta. So that's what we are going to use. Okay, 1 plus cotangent squared theta equals cosecant squared theta. We know that cotangent theta is x over 2, so I've written it as 1 plus x over 2 squared. Cosecant theta we know is y over 3, so y over 3 squared. So I can write this as 1 plus x squared over 4 equals to y squared over 9. Now we are done. Yeah, we are done. So you can write it in different forms, okay, depending on the question, how the examiner wants your answer. So if you multiply throughout by 9, you'll get 9 plus 9 over 4 x squared equals y squared. Okay, if you multiply throughout by 9, you'll get 9 plus 9 over 4 x squared equals y squared. So that's what you see here. Okay, and we're done. Next example, we are asked to find the Cartesian equation of the curve given by the parametric equations x equals to t to the power of 3 over 2. That's what we have here, and y equals to 4t cubed. So we are given the parametric equations and we have to find the Cartesian equation. So remember the idea, we need to get rid of our parameter. Yeah, we need to get rid of our parameter. So I've started by writing x equals to t to the power of 3 over 2. So using indices, we can write t as a subject and write it as t equals to x to the power of 2 over 3. So let me help you a little bit here. So x equals to t to the power of 3 over 2. So if I want to get t on the right hand side, I need to do this. Okay, t to the power of 3 over 2 and take it to the power of 2 over 3. So I must do that on the left as well, and I'll get x to the power of 2 over 3 equals t. Okay, so playing around with some indices, therefore you'll get t equals to x to the power of 2 over 3. What's left? Plug into the second equation, y equals to 4t cubed. I've done that here for you, where you see your t, plug in x to the power of 2 over 3, and using some indices, the 3's will go. We are left with y equals to 4x squared. Next example, we are going to be dealing with points of intersection. So this is quite important. Find the points of intersection of the curve with parametric equations x equals to 2t minus 1 and y equals to t squared, and the straight line y equals to 3x minus 2. So what are we going to do in this example? We are going to learn the technique to handle all questions involving points of intersection. So remember, the idea is we are going to perform simultaneous equation solving. So that's what I've done here for you. Equation number 1, we have the first set of equations, the parametric equations, x equals to 2t minus 1 and y equals to t squared. I'm calling these equation 1, and equation number 2 will be y equals to 3x minus 2. So like in simultaneous equations where we solve using plugging in, I am plugging in 1 into 2. I'll repeat, I am plugging in equation 1 into equation 2. So look carefully, equation 2 is y equals to 3x minus 2, so y is t squared. That's what you see here on the left. 3 times x, what is x? 2t minus 1 and minus 2. Okay, so plug in 1 into equation 2, and what's left? You have to clean up the algebra. Yeah, you have t squared equals to 60 minus 3 minus 2 is minus 5. Write a quadratic equation, you'll get t squared minus 60 plus 5. Solve this quadratic equation and you'll get two values of t equals to 1 and t equals to 5. Now that's not the end of the problem, because we are looking for the points of intersection, so we need to give x and y values, but we know how to do that already. So t equals to 1, let's find, okay, the x value and the y value. Okay, and after that, when t equals to 5, we need to find the x value and the y value. Again, we have found the values of t equals to 1 and t equals to 5. So when t equals to 1, you need to find the x value and the y value, and when t equals to 5, you need to get the x value and the y value. So you'll have the 2 points of intersection. So follow carefully the answer. T equals to 1, plug in x equals to 2t minus 1, you'll get x equals to 1, and y is t squared, so 1 squared will be 1. So the first point of intersection will be 1, 1. When t equals to 5, plug in 2t minus 1, 10 minus 1 is 9, t squared will be 5 squared is 25. So I have my second point of intersection, 9, 25. Now let's look at another example involving points of intersection. Let's read the question first. The curve with parametric equations x equals to a times t minus 2, y equals to 2at squared plus 3. That's what you see here. A is not 0, and this curve meets the y-axis at the point 0, 4. And what are we asked to find? We are asked to find the value of the constant a, and we are asked to find, or rather hence determine, whether the curve meets the x-axis. The question says meets the y-axis at the point 0, 4. So when a curve meets the y-axis, you know that x equals to 0. Okay, so set your x equals to 0, write a times t minus 2 equals to 0. Therefore you know t equals to 2. The question says that a cannot be 0, so t equals to 2. They gave me the y value, it's 4, but we know that y equals to 2at squared plus 3, and we already know the t value as 2, so that's what you see here. Okay, 4 equals to 2at squared, so it's 2 squared, plus 3. Clean this up and you will get a equals to 1 over 8. Now you asked to determine whether the curve meets the x-axis. So when the curve, or rather when any curve meets the x-axis, y equals to 0. Okay, that's a fact. So let's go ahead and set it up. Y equals to 2at squared plus 3, so y is 0, so 0 equals to 2 times a, 1 over 8, t squared plus 3, and when you clean this up you will get 1 over 4 t squared equals to minus 3. This cannot be, yeah? Or if you like, you can write this as t squared equals to negative 12. So when you square something, you cannot get a negative number. Okay, therefore it cannot be. Therefore this curve does not meet the x-axis.